Hi guys, design time again. Well, not a extremely complicated project, but a very useful one, at least for me. Some time ago, some time is good, a couple of years ago, I bought myself a Rubidium reference, an FEI FE5680A. It is an adjustable one, this version, and for that I needed something that I connect to the DB9 connector that is used as the only connector on this reference. I will show you how this reference looks. This is the thing. It's quite beaten up. And when it came, it had only this 9-pin DB9 connector. There are really a lot of variations of this reference, and the usage of these pins, of the DB9, is totally different or much different with the variations and the options you have on the 5680A you have. For example, mine did not have an output for 10 megahertz at all. On the DB9, it had only the PPS signal, pulse per second. It had a lock where the rubidium is locked, and the power supply of 15 volts up to 2 amps and ground. These was the only pins that were usable. That means everything else I had to bring out by myself. I will not open it because it's not a teardown video of this reference. There are so many teardowns of this reference, a well-known one. So in eBay, or you still see it a lot in eBay, and just Google it, FE 5680A, and you will find a lot of stuff. Anyway, I brought out the 10 megahertz on this funny connector. It's a MMCX connector, and on this 3-pin connector is the serial interface where you can configure the offset and the frequency of this reference. Other references, for example, have a fixed frequency, and at the side there is a small pot for the offset. This is missing, so that means that if you want to discipline this thing, you have to do it through the serial here. And this is something that I will mention a little bit later for what I bought these things. Of course, the first thing was to play, but then I thought, what usage I could have for this thing, and I started to design a quite complicated and extensive project that, as so many times, I got bored of it, or I got distracted for something else, and it's sleeping since, I don't know, 2019 or something, 2018. But forgotten is not cancelled. We will see. Perhaps in the future I will continue it. But anyway, this is the reference. For this reference, I needed something that to connect, to break out the lock indicator, the PPS, and something that, in general, to use it as a general breakout for other versions of this reference with other pinouts. Anyway, this is what I came out. Let's come closer. It is a quite old design. I don't know if we can see it somewhere here. Whoops, sorry. 2019, that's quite old. These two wires are not botch wires, they are planned wires. But this is the first, this is for the supply, the 15 volt 2 amps to the DB9 connector. This was the first revision of the board. This is all removed now. You have on the left side the connection to the reference, to the Rubidium reference directly. And on the right side, you have a DB9 where you have to connect a crossover cable to the PC, so you can use either a terminal program, terminal emulation, or a dedicated configuration program for this kind of reference. Power supply is here, barrel connector. With this version, still a power, the only possibility. You have the serial connection with a 3-port, with a 3-pin connector I showed you before, and some bridges that you can more or less configure this board. One of the bridges, 2 of the bridges are you using, because many of the some of the versions of the reference, of the Rubidium reference, have the RS-232 configuration port directly on the DB9 connector. So you can choose between the DB9 RX takes from the DB9 connector, or as in my occasion that I have to take it to break it out directly from the box on the 3-pin connector. There are some other options you have here. You have test points. And another option of the reference, you have the 10 megahertz sine wave, again on a DB9 pin 7. And I've provisioned here a small UBX, I think it's called like that, connector, RF connector, so you can break it out, you can connect it to whatever you want. Additionally, the PPS impulse here is 1 microsecond wide. You cannot see it. You have to use a scope, and it's optically not visible. What I did is I stretched it using a monoflop to up to 300, I think 340 or 360 milliseconds. That is enough so you can see it blinking, like on the UBX receiver boards. Then what other things you have here is you have indicators for locked on and locked off. This is if the Rubidium is locked to the PLL or not, green and red. Here you have the PPS signal optically so you can see it. Yeah, that's it more or less. Later I will show you how this works connected to the PC. This is quite old stuff, so there are a lot of software variants configuring the reference itself, but they are not working on a 64-bit operating system. So I will show you what you could use, you still could use, if you have a 64-bit Windows 10, 11 or something like that. This is the older version, the first version I made of the PCB, and for me it's working. I have no necessity to use the newer version, but long time ago the newer version has been made. This is how it looks. You have now the possibility for the barrel connector and a dedicated high current connector to power the PCB and the reference. Everything got a little bit smaller and a few more information on it. And the wires needed before are gone. And this is here, this part. Yeah, well, of course, all these things what you see, the design files are available and some information additional that I have. Why I bought this reference, the reason I bought this reference at the end was, come on, yeah, much better. Because I wanted to make a very stable 10 megahertz reference for my lab with distribution of the 10 megahertz to all my instruments that I'm using. So I have a central source of 10 megahertz for all my instruments. Everything would be, of course, isolated. The 10 megahertz, all the output would be isolated. Additionally, sine and square, both isolated, 10 megahertz. Then the 1 hertz PPS signal would be distributed or distributable, again isolated. And all these things I wanted to put on a 19-inch rack, mini rack, half height like that, this size more or less. And in this rack would be then NTP server with a GPS disciplined NTP server for network time protocol, and I would use this server to the PPS signal to discipline this one with, of course, additional circuitry that is needed. This project, as I told you, was sent to sleep 2019 or something, yeah. Once in a while, I pick it up again, throw some additional circuitry that I think I will need, and then I forget it again because I have other things in my mind. Okay, let's see how this board works. Okay, this is how it is connected. Power supply and the serial port itself. I'm applying 15 volts now. And the first thing we can see is that the lock is off and it's already sending the PPS, the parts per second, pulse per second signal is getting out. The signal is already stretched. You see how it is visible. This would be normally a 1 microsecond impulse and stretched up to 360 milliseconds with this monoflop. For this monoflop I'm using a FEI FE5680A timer, a CMOS version. For now it is drawing almost 2 amps because it's getting warm. This thing is totally cold for the moment. This is why it is still not locked. Here you see it a little bit better. Okay, let's leave it like that. I like it more. It is not locked on the Rubidium. This will take some time. On the scope, you can see already the sine output, 10 megahertz. It is still drawing over 1 amp, but soon it will go down when it's warmed up. When it is warmed up, it will draw 800 milliamps or something like that, but it still takes some time. The rubidium and the TDS are locked. It is still warming up, but we have a lock. This is why you see the green LED on. And the current is still going down. And now it's going rapidly down. This will stabilize somewhere at 800 something. So this is the condition now where we have the reference locked to the rubidium lamp. It's a very interesting physics. I'm not the right person to explain that. I roughly understand it, but for me it is interesting what I can do with it and not how it works, because I'm not a physician, a physic. If you're interested, Google is your friend. Okay, let's see how the programming would look when it's connected to a PC. Okay, I connected a USB to serial, cheap USB to serial connector, gender changer, and an additional cross adapter that is a null modem, that simulates a null modem. So I don't need a crossed cable, I can connect it directly. This is the example software I'm using. It's called Rubicon. It's quite old. I have selected COM4, the port 4, and it already have read that the output is 10 megahertz, and the reference frequency this is an internal frequency and some control stuff. When I press check, again, you get further informations. You see what the name of the reference is, some hex data, and the reference output, the output frequency in the reference. This is how you could configure the output. I don't want to change anything at the moment, but my version is configurable, and this is the way that it could be disciplined. That means you need a microcontroller that just trims the offset as necessary. Other versions of the Rubidium, of the FEI FE5680, have a 0 to 10 volt input where you can do that. This is not the one. Short explanation of the circuitry. On the left side you see the two DB9 connectors. On the bottom the one that goes to the PC. On the top the one that goes to the reference itself. The two connectors for the power supply, the configuration bridges, then the circuitry for the lock indicator, red and green, when the reference itself, the Rubidium reference, is locked to the TDS, and the stretcher for the 1 microsecond PPS impulse to make it approximately 360 milliseconds, so it is visible and to blink it and to show it with a LED. So this is all. It's not very complicated, but it's what I have. Next thing is what I want to do, or I planned to do more or less, how to discipline this thing. On the here you have the reference itself. That's a generic block diagram. The reference itself, some buffering, 10 megahertz sine wave or square wave, doesn't matter. Forget this 5 megahertz, I don't need that. The frequency divider too. We have the PPS itself from the reference itself. This will be compared to a phase comparator and controller, 4046 for example, yeah, PLL, with an external PPS impulse that comes from the GPS receiver, from the U-Blox GPS receiver. The result is an analog value that will be processed, and this controls the offset of the through the serial board of the configuration, the serial configuration board of the reference. We will set then the offset. This is the idea, more or less. The idea was and still is to build something like that, but not in this kind of enclosure, in a small 19-inch rack, but more or less with the functionalities. The keypad is redundant, I don't need it, but the outputs, all of them would be digital outputs for 10 megahertz, the sine outputs for 10 megahertz, and the PPS outputs, that everywhere would be at least 3 to 6, would be isolated. Just a small peek on what I was planning, or I'm planning to do, all the things that I already have made. For example, isolated serial port for the configuration, isolated PPS with stretchers and no stretchers, with up to 2 or 4 outputs. The analog filtering, the 10 megahertz filtering with a ladder, crystal ladder filter. This is one of the videos will come next to show you what I did and what breakouts I made. Preamplifier and final amplifier for the 10 megahertz. For 3 10 megahertz output ports, isolated output ports. Same here with the digital 10 megahertz. I'm cleaning the phase with the 4046. The whole thing is again isolated. The output, the digital outputs. I put even a signal detector to check if the 10 megahertz are here. Well, that's it for now. If you like my videos, if you like what I see, if you like my content, please press the like button and subscribe to my channel. This helps my channel to grow and helps, of course, me to show you more of my designs and other interesting stuff, or at least what I think is interesting. Here we have again the 10 megahertz. Thank you for watching, guys, and design files are available. This is how it looks. Cheers!